All right, so welcome back. And so let's talk about our demo using the Psych300 Data2 dataset. Say that 10 times fast. And so let's say that we were trying to answer the research question, does belongingness to STEM change over the course of a semester? And to answer that question, we surveyed Psych300 students like you, and then they were assessed on 3 measurement occasions: pre-test, post-test, and follow-up. And so while the design is very similar to what we have for the actual Psych300 Data2, just to let you know that this is fictional data that you're seeing in this demo. And so my numbers will not match up to yours if you were to test this question using your own Psych300 Data2 dataset. So with that caveat, similar ideas though, so hope that they translate well to your own analyses. So what is a dependent variable here? If you said belongingness to STEM, you're absolutely right. So that is our dependent variable. And what would be the independent variable? This one is actually a little bit tricky. This is a within subject factor that designates the time point or the measurement occasion. And so that would be the independent variable. So it's an interesting situation where you don't see a variable that designates this in the data set like you used to. In this case, it is a conceptual independent variable that designates the measurement occasions that are being compared. And so thinking about hypotheses, the null hypothesis might indicate something like there's no difference. Basically, there's no difference across those 3 measurement occasions. Whereas the alternate hypothesis would say there is a difference somewhere in the levels of belongingness across those 3 measurement occasions. And we don't know exactly where those differences are, but there's at least one difference in means across those 3 measurement occasions. And so translating that to population parameters, the null hypothesis would say basically that the population means are the same. There's no difference across those 3 time points or 3 measurement occasions. Whereas the alternate hypothesis would say that there is some sort of a mean difference across those 3 measurement occasions. And so that's the idea behind our repeated measures ANOVA. A quick note about data structure. And so when you hear somebody talking about using data in a wide format, then this is what it means. So the rows represent each case. So in this case, that is also true for us, that each row represents a person, a participant, or a case. And then the columns represent each level of the independent variable. And so, for example, in my dataset, I might have 3 levels of my independent variable. There's pre and post and follow-up as the levels, and they're represented by a column. And so if you hear a wide format data, this is what it means. The more you know. Okay, and so let's talk about running repeated measures ANOVA in RStudio. And so first of all, what you want to do is to create the within subjects factor within RStudio. Then you would run an LM model containing just the DVs. You would put that into the repeated measures ANOVA using the big capital A ANOVA function, which you've seen before and requires a car package if you might remember. And I'll give you the code for that shortly. And then if Mauchly's test appears to be significant in your output, then you'd want to make corrections to your degrees of freedom for your F statistic. And so let's break down these steps.
Break it down.
So go over the code in PowerPoint and then we'll move over to RStudio. But first of all, what you want to do is to create that within subjects factor. And so each level represents a measurement occasion. And so you would do that by creating the factor object and then using the factor function and making a list of the different levels of your factor. And then you can just plug in the ordered equals false as the remainder of that factor function. And then you would run an LM model, but this time you're essentially just using column bind or cbind function to represent the set of dependent variables that you have, so different measures of the dependent variable, regressed on 1. And so it's just essentially like an empty model that you're running, but this is something that is going to get plugged in into the next set of code. And so you want to save this LM model into an object, and this will make a little bit more sense once we see an example, I think. And then we will have the repeated measures ANOVA. And so we would use the ANOVA function, which requires a package car. And then you would want to give that particular LM model that you just ran, you want to plug in that object here and then fill in the rest here. And then the factor object that you created in step 1 would go in here and here. Once you save this entire long model into an object, then you can run a summary on it. And be sure to tell RStudio that multivariate equals false, otherwise you're going to get some different output that you don't need. In that output, you will see the Mauchly's test. And so if you get a significant result for the Mauchly's test, then you'd want to correct the degrees of freedom in the way that we talked about. So choose your epsilon and then multiply epsilon and degrees of freedom. And so you will have lecture code as a way to get that done. So here are the basic steps. Now let's hop on over to RStudio and party our way through the repeated measures ANOVA. See you there. Alright, so welcome back to RStudio. It's a beautiful day in here and I have already set my working directory, imported my data, and then attached the data set. And so if you were following along, which I encourage you to do in your own RStudio, I would encourage you to set up your environment this way as well. And I know that I'm going to need the car package, and so I'm just going to load it for now. And then I've started to jot down my code for each of the steps that we talked about. So you might remember that the first step is to create your within subjects factor. And so this is something that you do manually. And so I've called my within subjects factor time point. And in that, I have saved a factor which has a list of these 3 time points. And so these are things you can name on your own. And so you can see that they're in quotation marks. I've named them pretest, posttest, and follow-up. But depending on your preference, you could do like time 1, time 2, time 3, or whatever you'd like. But in this instance, for ease of comprehension, I have done pretest, posttest, and follow-up. So these are the 3 different measurement occasions. And then ordered equals false. And so let's run that. And so I now have an object called time point, and it is a factor with 3 levels. Great. And then step 2 is that you want to create an empty regression model that could be read into the big capital A ANOVA function. And so I've just called it empty model because, imagination. But that has the LM function, which has the cbind, and here is the model. And so within the cbind, I am binding those 3 variables that represent those 3 measurement occasions. And so we have belongs them pre, belongs them post, and belongs them follow-up. So these are actual variables in my data set. And so 1, 2, and 3 corresponding to pretest, posttest, and follow-up. And so they are in the cbind and then regressed on 1. And so I'm saving that model, LM model, into empty model. And then we're ready to run the repeated measures ANOVA. And so I've already loaded the car package, but if you haven't done so, make sure to load the car package. And so I'm just going to call it RM model. And so let's see what's inside the RM model, which has this busy ANOVA function. And so within this capital A ANOVA function, we first let R know what model we're working with, which is the empty model I just created. And then this is information to let R know that we're working with within subject factor. And so I have within subject factor of time point saved as an object. And so I would include that in this idata equals data.frame parentheses over here. And then also mentioned here iDesign equals and then tilde time point. So again, whatever you called your within subject factor should come in here. And then type equals 3 in quotation marks. And then you can go ahead and run that to obtain that RM model. And so, if you're looking at this and going, this is overwhelming, the best thing to do probably is to just repurpose my code. Just know which information you have to update and which belongs to the original code, and you'll be okay. And then I'm just gonna save the summary. So oftentimes we just run the summary and then mention the model. This time I'm gonna save that as its own object because it's potentially gonna be useful a little bit down the line. And so we've got the summary of this RM model that had been created, comma, and then include the statement multivariate equals false. And so we have this summary and you save that into an object, however you like to call it. In my imaginative state, I'm just gonna call it RM model summary. And as we do that, I just want to show you a quick tip, which is that you can also ask RStudio or R to print out your object automatically by surrounding that statement in parentheses. And so you could either run this, and then you could, of course, print the function by just typing its name and then by running that code. But if you didn't want to do that, just FYI, you could also enclose this entire statement in parentheses and then try running that. And what it does is actually to print out, so you're seeing it twice, but if you just do that, then it will automatically print the result for you as well if you include the entire line in parentheses. And so that's a nifty trick in case you want to save some time. And so I'm just going to keep this in my code for you for reference. So, these exterior parentheses are allowing you to print your RM model summary, which is pretty nifty, isn't it? And so we've now obtained our repeated measures ANOVA model. Hooray! Now this is all very exciting, but we do have to actually read what R printed out. So let's take a look. And so here is our repeated measures ANOVA table, where you can see the ANOVA result for your within subject factor, which is time point over here. Now, do you always interpret this line exactly as it is written? You may have said no, because you're catching on that we actually have to look at the Mauchly's test and figure out whether the sphericity assumption is met, and otherwise we have to make corrections. And so let's take a look at the Mauchly's test over here, right below the repeated measures ANOVA for convenience. And so if you take a look at this and you may be wondering, what is it? If you have trouble with this, you can always go back to the format function. And so you can just copy this over. And then you might remember that you just turn off the scientific notation. Whew, that is a tiny p-value. I usually don't see p-values this small. Now, is that good news? Did we meet the assumption of sphericity? Or is that not so good news? We did not meet the assumption of sphericity. You might have said, it's actually not good news. Then you are right. And so now we can't assume sphericity like this output is doing. We have to actually make corrections. And so we are now looking at which correction to make. Is it going to be Greenhouse-Geisser or Hyunh-Feldt? And so here down below are the epsilons. And so here is the epsilon for Greenhouse-Geisser. And then here's the epsilon for Hyunh-Feldt. And if you just rifle through your PowerPoint slide to go back to the sphericity information, then you might remember which correction to go with. And so can you let me know which correction to go with? If you've mentioned Greenhouse-Geisser, because epsilon is small, less than, let's say, like 0.75 or so, then you are right that we want to use Greenhouse-Geisser correction for this particular model. And so there's a little bit more work to be done before we can actually write up and interpret our findings. And so you may sneakily see some code here. I've taken down some notes for you. And so yes, Mauchly's test is significant, so now we have to make corrections, right, to our degrees of freedom. Now, something that could be useful to do is to first of all save the original numerator and denominator degrees of freedom. So I've called it degrees of freedom 1 and degrees of freedom 2. Now, here I would say go ahead and just repurpose my code, so sit back, relax, and enjoy the ride. And so what this code is doing is to save degrees of freedom 1 and degrees of freedom 2. And that is taken from the RM model summary, which we are seeing over here. And this latter portion is calling information from this table. And so second row, second column is the numerator degrees of freedom over here. And then for denominator degrees of freedom, then we're calling the information from the second row, fourth column of this table. And so this would be the denominator degrees of freedom. And so we're saving those degrees of freedom. And so I am going to run that code. And if you're feeling uncertain about what this did, then you can always print out those objects, right? So let's say like degrees of freedom 1 checks out 2. And then degrees of freedom 2 would be the denominator degrees of freedom, which is 212. So checks out, looks good. And so we've saved those degrees of freedom, and now we have to make corrections to them. And we're using the Greenhouse-Geisser correction. And so what we want to do is to multiply the epsilon, Greenhouse-Geisser epsilon, as a correction factor with our degrees of freedom for both numerator and denominator degrees of freedom. And so what I'm going to do is to just save the Greenhouse-Geisser epsilon as ggEps. And so you can repurpose this code, but once again, make sure to update the summary model information if you need to. But you can use the $p_val.adjustments and then in brackets 1 to save the Greenhouse-Geisser correction factor over here, epsilon. And so that's ggEps. And so if you're curious now, what is it? Let me just demonstrate. So here, the same thing, Greenhouse-Geisser epsilon is saved as ggEps. And then you can ask R to calculate the corrected degrees of freedom by running the calculation. And in this case, I'm saving it as ggdf1 and ggdf2 so that I can come back to it later on as needed. But basically, multiply the ggEps by degrees of freedom 1 for numerator degrees of freedom, and then multiply by df2 for the denominator degrees of freedom that applied the correction. And so let's run that. And then let's get those printed out. And so here we are. And so here's the numerator degrees of freedom with correction made. And then here's the denominator degrees of freedom with correction made. All good. And so we have made the degrees of freedom corrections. So what happens to our repeated measures result? Now be careful, because once you make corrections to degrees of freedom, the p-value will change. The f-value will not change, but the p-value will. And so then you can take a look at this section where you're also given the Greenhouse-Geisser epsilon. And here is the correction being made to the probability or p-value for your f statistic after the Greenhouse-Geisser correction is made. And so there's a little bit of nimble navigating back and forth, but you can get the numerator and the denominator degrees of freedom like this that are corrected. And then the f statistic is still here, same f value. And then the corrected p-value to report would be here, because over here is a p-value when you can assume sphericity. Here is the p-value when you cannot assume sphericity. And so this is the corrected p-value, and so you want to report that. Now in the alternate universe, if you need to apply the Hyunh-Feldt correction, you can always use my code and repurpose it. Again, make sure to update the model summary information as needed. But in this case, you would be saving the p-val.adjustments 3 for the epsilon, which is shown over here for the Hyunh-Feldt correction factor. And then you can run this code and then get the corrected degrees of freedom. And so there you have it. Wow, wasn't that quite the ride? So now let's reconvene in PowerPoint and wrap up this phase of our lecture. So great job so far. You know what repeated measures ANOVA is and how to run it in RStudio. In the next video, we'll talk about how to interpret the results and write it up, and then we'll conclude with a summary. And so please feel free to take a break, get hydrated, stretch, exchange a high five with a friend, whatever you need to do in order to stay fresh. And so meet you back in the next video. Talk soon.